Hey, so I want to talk a little bit about dealing with the motorcycle data set. So this is a really cool data set. There are a lot of data here, a lot of different ways you could break down these data. So just in Excel, for example, you could, um, subset some of these data into just the non-fatal injuries and focus on those by town. You could do it set for all of those different things, fatal versus non-fatal, and exclude the other ones. So different ways that you can compare subsets of this data set. There's a date information in here in terms of year, and then also like month of year. So you could actually, break this down into summertime crashes versus wintertime crashes and where those tend to end up. All right, so this is an Excel file. Excel and GIS don't play nice, so I am going to save this file as a comma separated values, a CSV file, which GIS is kind of into. I have also downloaded the towns data from Mass GIS, so I just Googled Mass GIS towns. And here's a polygon layer of that. All right, I just saved that CSV into my temp directory, so I should be able to now bring in the motorcycle crashes. And always first thing, open it up, make sure it actually looks like something, right? Okay, the other key piece of information in here is where are my spatial attribute information? And I should have looked at that in the Excel one because it's kind of dizzying to scroll through this whole thing. Aha, but here they are, X and Y. And if you look at the metadata for this data layer, well, first thing you always ask yourself, is this a geographic coordinate system? The answer to that should be a quick no, because these data values are way too big to be decimal degrees. No way this is latitude and longitude, so it must be some sort of projected coordinate system. And so anytime you have a projected coordinate system, first thing you look for, metadata, some other information that's going to tell me what these units actually are. So if you go into the README file, you will see that these values are in mass state plane. One nice thing, this is where GIS works in our favor, is that I brought in this town's polygon, so that set the data frame to be the mass state plane projection, because that's what the projection is of all mass GIS data. So when I go to, you remember you did this in lab 5, display those XY data, I need to find Y. For Y, it will automatically suggest my mass state plane projection, which is what my motorcycle crash data should look like. Okay, so they show up, they're in Massachusetts, that's always a good sign. Remember, this is just a visual display of these point data. So if we actually want to manipulate them in some sort of shapefile, then we need to export this to, so Moto 2010 to 2015. And here comes my shapefile. And now I don't need the event layer or the table anymore. All of that information should now be in my shapefile, and now I can see the total number down here because it's actually a shapefile as opposed to a table that GIS didn't feel like reading in its entirety. All right, so let's say, and remember you can break this down any various different ways, like the type of injury or the collision type, or whether this happened at an intersection or whatnot, who was the age of the drivers involved. Lots of different ways that you can choose to approach your final project. I'm just going to do this really simply and ask the basic question of, for all of these 10,708 motorcycle crashes, are there towns in Massachusetts that had a higher proportion of motorcycle crashes per capita than others? So what we you'll notice that actually one of the things that's in here already is the name of the town. That may join really nicely into the town survey. Sometimes miracles happen, and since this is all coming from Mass GIS, there's a good chance it would work. But I am an untrusting soul, and I prefer to pull that information in myself, that information about the town survey. So that's your spatial join, which you did in Lab 7. Starting with our motorcycles, pulling in the information about the name of the town, plus whatever other attributes we feel like. This moto plus towns. Here's our giant list of all of the information that's getting pulled in, and this might be a little overwhelming at this point, right? So the main thing that we actually care about is this town from our towns poly, all this other stuff. You could just remember that, or you could start deleting, delete a whole bunch of stuff so that you don't have to worry about all of that stuff. And then everything else comes from your motorcycle data set. So I'll just hang on to that stuff, and we're just going to append town. Okay, so here's my motorcycles plus towns. I have all my original attributes plus town at the end. And the reason that I did this is just because GIS is real finicky, right? If it's going to be all caps, it better be all caps in both of them in terms of doing the join. If there's an extra space in something, there should be an extra space in whatever you're trying to join it to. And so this just reduces the likelihood of errors if I'm trying to analyze something later on. Okay, so I've got 10,000 plus motorcycle crashes, and what I want to know is how many of them are there in each of these towns. Well, I've got town appended on here. Remember back to Lab 2, our handy summarize tool. The basic thing that summarize does is to, I'm going to save this as, well, I can save it as whatever I want, but let's make it a text file. The basic thing that summarize does is count the number of things that are similar, right? So this is crash per town. And let's open up crashes per town. And so what you should see is the name of the town and the total number of motorcycle crashes. And this again is all the motorcycle crashes. If we add up this total number, it should still sum to that. Oops, it's only adding the one that I've got selected. We add up the whole thing, it should still sum to that 10,708 that we started out with, because there were 10,708 rows, right? Now we've just merged some of them together to know that there were 69 total motorcycle crashes in Auburn, for example. Okay, this is a lovely join table, right? So I can, here's the names of all my towns, here's this information on numbers of motorcycle crashes. I want to get that back into my polygon data. Just going to turn these off. So that is a join. And I'm going to do it based on town, and town, crashes per town, off we go. And so what should happen now is all the way at the end of this, I should have a repeat of the town and then the count of the number of motorcycle crashes in that town. This data file is kind of interesting. There were however many towns, 333 towns, but you can see that there are 1243 polygons here. That's because you see like some of these coastal towns have multiple bits to them because they have islands or something like that. The important part is that count town is now appended to this. Now, you probably have a better memory than I do, but I can remember right now that count town is actually numbers of motorcycle crashes, but I'm not going to remember that tomorrow. So I'm going to do myself a favor and call this, call it N moto. And a short integer should be fine, because these are numbers 1, 2, 3. And motocra, I don't really like that. I'll take out my underscores. And a vowel, who needed that? And with field calculator, I can just set this to be the same as that last column, count town. They don't always have the same names in here as here, but they're usually pretty similar. And this is just saying that there were a couple of null values. So like null here, and it just gave it a 0 value. So that's acceptable by me. I'm going to remove the join so that I don't have to see that anymore, because now I have named it, you know, number of motorcycle crashes, and that's going to make sense to me. I can call this something longer if I want to actually understand my pigeon going on there. Okay, so we've got number of motorcycle crashes. The other thing that we want to bear in mind is that there are some places with a lot more people, right? And probably with a lot more motorcycles, and therefore with a lot more motorcycle crashes. So another nice thing in the Mass GIS towns layer is that it has the population from 2010. Hopefully you've all filled out your 2020 census information. That's not available yet, but will be within a couple of years. So I would like to know crashes per person, right? So I need to take this and divide it by that. Before I can do that, I need a place to put it. Crash person. I'll rename that in a second. Floating point, because we're looking for numbers that are between 0 and 1, right? That's going to be a fraction. Crash perso, love it. Let's go to properties. Call that something a little bit more intelligible to me. Field calculator, don't want that anymore. What I do want is number of motorcycle crashes divided by population from 2010. Okay, and so I end up with moto crashes per person. And this is a cool data layer that I can now visualize, right? Because I've got some survey data, or not survey data, town data. I've got some quantities now, moto crashes per person. I can put this in some quantiles. There are some that have, you know, pretty high numbers of motorcycle crashes per person and some that are relatively low. We bump that up a little. And let's make it like a red color ramp. So low values of motorcycle crashes, high values of motorcycle crashes. And cool, we get kind of this neat spatial pattern, right? So for whatever reason, Hadley has a pretty high value of motorcycle crashes per person, 0.004, you know, and we can look around and see at some other ones, like, and speculate as to why Hadley and Palmer have such high motorcycle crashes per capita when some other places don't. So those are some tools to get you started. I would encourage you not to look at all the motorcycle crashes, but to do this type of analysis for comparisons that you want to make, like fatalities versus non-fatalities, or ages, you know, different ages of the drivers or of the different vehicles, whatever floats your boat in that giant Excel table. Is a good way to visualize and play around with these data. So enjoy.